Okay, now let's go ahead and do number 4. So number 4, actually Roman numeral 4, is going to be on how we can prepare the starting material. So preparing the starting materials. So we now understand the major reactions involved with this organometallic chemistry. We understand how to count electrons. We understand the types of reactions that take place. Now we need to figure out how do we get the substrate and the other molecule that are going to come together in this reaction. So the first thing we're going to do, number 1, is let's talk about how to make the substrate. Remember? So we have our substrate. So for example, over here we have a substrate, and then we have this piece here, which is either an alkene or some other alkyl group with a metal on it, right? So right now we're dealing with the substrate. Now, remember I said that in general, a substrate has a leaving group, right? So what is the leaving group? Well, the first one, which is pretty obvious, is a halogen, right? So we know from last semester, halogens are leaving groups. But other things that we talked about last semester are things like OTF or OMS, right? So our triflate, our mesylate, our tosylate, OTS, these are all leaving groups, right? These are all just things that can leave from a carbon. And then as far as the R goes, the R could be any carbon type. So it could be sp3, it could be sp2, it could be sp. That doesn't matter. So any degree carbon as well. So it could be primary, secondary, tertiary. So any carbon type will work. So primary, secondary, tertiary, doesn't matter. So our substrate has 2 components, and now we recognize that this is a very, very flexible reaction. There's very few limitations to it. Actually, there's no limitations that we need to discuss in particular. So this is what we're going to focus on. So now, the most important thing is that if it's an sp3 carbon, it's not that it won't work, it's just that it's not useful. What makes this so useful is taking double bond or triple bond carbons and connecting them to other carbons. So that's really where the use comes in for this whole thing that we're learning about, okay? So it's most useful when the R group is sp2 or sp. That's the best conditions for when you would want to use organometallic chemistry, okay? So let's talk about A. The first thing is, how do we get an alkyne to become a vinyl halide? So this is going to be one of our substrate creations, right? We're dealing with substrates. And so let's say we have an alkyne like this, and we were to treat it with HBr. Okay, now if it's 1 mole of HBr, because if it's 2 moles, then it's going to come in twice. We don't want 2 BRs. We want 1 leaving group. So what happens here is that you wind up making an H come in first. And so remember how double bond or triple bond in this case breaks, you get a carbocation. But the reality is you don't really get a carbocation. So the H goes here. But if you remember from last semester, it kind of hovers around the other side as well. So the H is actually positive. So what happens is when you have an alkyne, you don't want to make the carbon positive, that's sp2, and the way that you avoid that is by pushing the positive to the H. So the electrons kind of circulate between the H and the 2 carbons next to it. Okay? So, but why am I showing this to you? Well, the reason why I'm showing it to you is because it shows us that the Br is going to come in opposite of where the H is. That's why I'm showing this. It's an anti-addition. Okay? So Br comes in opposite, and we wind up getting a Br here. Now you might say, well, why did I even show that intermediate? Well, in this case, it really didn't matter. But let's say, for example, we have an alkyne like this with HBr, then what you need to recognize is that you make an alkene, right? If the Br goes here, you have to realize that the methyl's also down there with it. So because the H is blocking the top, right? So if the H is on top like this, and these methyls are like that, then when the Br comes in, it's going to come in pushing this open, and now you could see how the Br is going to be on the same side as the methyl across from it, right? So that's why it's important to recognize this characteristic. Okay, so that's the first thing. We could make a substrate like a vinyl bromide by doing what I just showed you here. Okay, now there are other examples. So another example with an alkyne, let's say you want the Br on the end. So notice how up here I put primary, secondary, the Br goes secondary, right? But what if you want Br primary? So in that case, we take our alkyne, primary and secondary, and we write HBr, but we do it in peroxide. Remember how in peroxide, the Br winds up on the lower degree. So now we get an alkene with a Br up above, and then the methyl is going to be the carbon that's a higher degree is going to be where the H goes. This is a radical intermediate, so you get that intermediate here, and then from here the H comes in. So trans is actually favored over cis. So trans is favored, right? So this is a way that we could put a Br on the lower degree carbon. These are ways of putting Brs on higher degree carbons. Okay, so this is all hopefully review from last semester. Okay, now one last one that has to do with an alkyne is actually no, that's it. This covers the ones I want to talk about for this particular topic, A. Now let's talk about B. So the next thing is, how do we make a carbonyl into an OTF or alternative, OTF, OTS, one of these leaving groups, right? These OTF or OTS, right? Or OMS, one of those leaving groups from last semester. So let's say we have a carbonyl and we need it to become both an alkene that has a leaving group on it, right? So we could use TFCl or TSCl or MSCl, doesn't matter. And we also use these in a base. Now I think there's too many here to write. All right, well, actually I'll just do it. So this plus some sort of base like pyridine, okay? So this is in pyridine. Now what this does is it allows us to make an alkene. And so the way we do that is if we have an H here, alpha, we pull that H, this becomes a double bond, and this goes up to become O minus, right? So we get this with an O minus. Now you might say, why did I pull from that carbon on the right? Why not the carbon on the left? Well, the truth is you could pull from both sides, but I'm going to focus on this one. You could have done this, is what I'm trying to tell you, but you'll see in chapter 18 why the other one's more favored. And I think you could see it, right? It's a more stable alkene when it's in the middle rather than on the end. But they both can happen, so I'll just kind of, I guess I'll list it out both ways. And now from here, we get, for example, TFCl, or any of those other two, TFCl, TS, or MSCl. And now this is going to come in, and the Cl is going to leave. This is going to come in, the Cl is going to leave. And now we have an alkene that has an OTF leaving group. See that? So now, again, we have a leaving group instead of halogen in OTF. And now we're ready for this substrate to go in and react with something else through the organometallic reaction. So this is how carbonyls become these leaving groups. Remember, these leaving groups are just big sulfonyl groups, right? So this is always the same. And then there's an R here. And so if it's, let's say, a TFCl, a triflate, then the R is going to be a CF3. That's what R equals, right? So instead of R, we would put that right there. If it's a mesylate, an MS, then it's a CH3, okay? If it's a tosylate, then it's a benzene that has a methyl on the end, a toluene. Remember toluene? So these are the different R groups, but they all have this same thing in common. They have a sulfonyl group with a Cl on it. And so that's what this is. You just don't have to really draw it, so we write OTF or OTS instead of drawing out the big structure with the sulfur, okay? So that's B. And again, this is all review. Nothing here is new. This is all review from last semester. Okay. Now, C is, let's say we want to make an alkene become a vinyl bromide. So let's say we want to make that right here. So I'm just trying to figure out ways to make substrates that are popular for this exam. So if we have an alkene and we write Br2, then remember last semester we get 2 Brs to come in. Now, if from here you write NaNH2 or NaH, these are powerful bases, what happens is that you wind up getting an alkene with a Br still on there. So for example, we could pull this H off, make a double bond, and this Br leaves.